Why are some bottles of paint so amazing, while other colors from the same line are so disappointing? Welcome to Goobertown Hobbies. My name is Brent, and I think it's always worthwhile to get to know our art supplies a little bit better. Today we are talking about pigments. These brilliant powders are what give paint their colors. In this video, we're going to talk about what these actually are, how they do what they do, and how all that affects us as painters. Let's start with the basics. Paint is essentially a pigment powder mixed into a medium. In this quick demonstration, I'm going to mix up an acrylic paint. I'm using Liquitex Matte Acrylic Medium, which is primarily a suspension of acrylic polymer in water. That acrylic plastic binder is going to give our paint its adhesion, durability, and sheen. Most paint pigments are not water soluble, so the acrylic polymer also serves the purpose of keeping the colored pigment suspended in the liquid. I'm mixing in this bright pigment powder. What we're stirring up here is properly called a mixture or a suspension. Neither the polymer nor the pigment is truly dissolved in the solvent of the medium. No chemical reactions are happening either. No covalent bonds are being made or broken. We're just dispersing the powder throughout the medium, and there are just enough intermolecular attractions between the solvent, the acrylic polymer, and the pigment to keep everything suspended for a little while. As we all know, if we let this mixture sit long enough, gravity will eventually separate this paint back into its component parts. But for a little while, it's useful to paint things. This paint that we mixed up real quick seems to actually be working. We didn't measure out the medium or the pigment, we didn't mix it all that well, and yet here we are painting a happy little drukhari kabalite warrior. This is why I find paints fascinating. They're so simple, and humans have spent hundreds of years fine-tuning them. And yet, some of the bottles of paint we buy still disappoint us. In my own collection, I have a handful of different paint brands, and they all have strengths and weaknesses. Sometimes those strengths and weaknesses are bottle by bottle. I love this blue, but I hate this purple. Within a single line of paints, some colors will be great, and some will be thoroughly mediocre. Us painters are always talking about our favorite new color from one line or another, or we're complaining about the coverage of some other color over black. Here in the 21st century, why can't art supply companies just make all of their colors equally good? Well, this will make a lot more sense when we talk about what pigments actually are. We'll start by looking at my own collection. My model paints don't list which pigments they use, and neither do these cheap craft paints. Luckily, good quality art supplies do tend to list which pigments they contain. Both my Liquitex and my Dollar Rowney acrylic inks list their pigments. Some contain a single pigment, while others contain a combination. Here are some that crop up a lot, and you may have heard of before. PW6 White Pigment 6 Titanium White. PBK7 Black Pigment 7 Carbon Black. PV19 Violet Pigment 19 Process Magenta. PR170 Red Pigment 170 Naphthol Crimson. PB15 Blue Pigment 15 Phthalo Blue. With the exception of Carbon Black, those are all pure compounds. There is a caveat here that slight impurities in pigment powders can give fun little color variants, but that's a topic for another day. For today, we're talking about pure sources of each of these pigments. The big point I want to make here is that on a molecular level, there are vast differences between these powders. On the screen, I've drawn out the structures for the 20 or so pigments that are in the acrylic artist inks that I happen to own. As painters, we know that all paints are not created equal. This makes a whole lot more sense when we look at how different they are chemically. There are a few families of compounds in this set, so it's not complete madness. But still, let's marvel at how much chemical diversity is in the pigments just from the inks that I happen to own. For fun, I also looked up the pigments used in Vallejo's Artist Acrylic line of paints. That set of 77 paints uses a total of 39 different pigments, many of which overlap with the pigments in my Liquitex and Dollar Rowney inks. One issue for us to think about is that all of these distinct molecules and compounds are going to have different solubilities. Solubility, or more accurately, the ease with which these compounds form a dispersion, is a big consideration for mixing up a paint. Let's do a quick visual demonstration here. I'm pouring mineral spirits, water, acetone, methylethyl ketone, and matte medium into vials. Then I'm going to spoon in some pigment powders. I bought some cheap baggies of common pigments from an Etsy vendor. Then I picked 5 pretty colors for this little demonstration. Several of these are the same pigments that I just showed the structures for. They're all distinct compounds, and they're all going to behave a bit differently in these various solvents. A quick side note, I should have modeled better safety here. In this case, I know what I'm working with, and I'm not concerned about any of these interfering with my health or with the cat on the pillow behind me. That being said, I literally just told you that pigments are a vast and diverse collection of different chemicals. Just because your blue is safe does not mean that your red is safe. Most commercially available pigments are reasonably safe these days, but that hasn't always been the case, and dangerous pigments are still out there. Cadmium red, for example, was common until pretty recently. Heavy metal poisoning isn't something to play around with. If you ever have safety questions about a chemical, look up its MSDS, Material Safety Data Sheet. If you're still not sure, throw on some gloves, goggles, and a mask to be on the safe side. You can also look up MSDS sheets for whole paint ranges. That's useful if your preferred paint line doesn't list the actual pigments on each bottle. Those safety sheets should call out any ingredients that are known to be dangerous, and they'll tell you which colors contain those potentially harmful compounds. Okay, back to seeing how these diverse chemicals mix with different solvents. When I'm working on a model, I prefer to use paints that don't separate out too quickly. I like to pick up a bottle, give a few quick flicks of the wrist to make sure it's mixed, and then get to painting. In my painting videos, you'll hear me complain sometimes about various bottles of paint for separating or being too thick or chunky or chalky. As consumers, it's so easy for us to blame the manufacturer. Why couldn't they just make all of their paints equally good? Is that so hard? Actually, yes. There are massive challenges to getting all of the colors in a line of paints to behave the same. This is the episode where I empathize with art supply companies. Over the years, humans have used hundreds or even thousands of different pigments. In addition to their different colors and solubilities, manufacturers need to consider color intensity, opacity, cost and availability, chemical durability, human safety, and a whole host of other properties. For this little demonstration, the point is just that these 5 pigments I chose behave different. None of them are truly soluble in any of these liquids, but some of them do form decent dispersions, while others separate out immediately. And, unsurprisingly, the behavior of each pigment varies with the solvent. For the 4 solvents I tested, the pigment separated out after no more than an hour or 2. For the vials with matte medium though, 2 days later and the suspensions were still pretty good. Acrylic Medium does a nice job of keeping diverse pigments in suspension. The mixtures in these vials are essentially low pigment paints. Let's give them a whirl, shall we? I obviously didn't measure or calculate the proper amount of pigment in these tubes. I just shoved a little spoon of powder into a squirt of medium. Clearly these have less pigment than the paints I normally use, but it's actually kind of working. Not too bad. It gets back to this point of paints being deceptively simple to make, and in some ways it's just a matter of fine-tuning things from here. Clearly, all of these would benefit from higher pigment density. I decided to add a heap more pigment powder to each tube and try again. At a certain point, it'll be tricky to keep all this pigment in suspension, but I'm pretty sure that the medium can take a lot more than what we started out with. Paint makers need to make choices about what pigments and pigment densities they want to use across their line. A medium that works well for one pigment might not work as well with others. The design of the medium also affects a bunch of other aspects of the painting experience, like how paint flows off of a brush. There's a whole bunch of interesting choices and compromises that these design teams need to make. Like I said, this is the episode where I try to empathize with art supply companies. I assume they're doing their best to negotiate a whole bunch of real-world challenges to bring us a nice product. For mixing my homebrew paints here, I really like my Vortexer, but I've got something even better. Ultrasonication is another way to get materials mixed up into a nice suspension. I've got an ultrasonic cleaner here loaded with water. I put the tubes in the bath and set the timer for 30 minutes. All of those tubes I'm mixing up are single pigment paints. Lots of my artist inks also contain a single pigment, but many of them contain a blend of 2 or more. This Liquitex dark green is green 7. This yellow is yellow 138. They also sell a lovely vivid lime green that comes with a mixture of yellow 138 and green 7. This all makes sense to me. Dollar Rowney sells a similar light green which contains 4 pigments. Green 7 again, plus 2 different yellow pigments, yellow 3 and yellow 74. Notably, it also contains some white 6, titanium white. So those 2 companies use 2 different strategies to get roughly the same color. The biggest difference between this Liquitex lime green and the Dollar Rowney light green is the transparency rating. One is transparent and the other is semi-opaque. From reading enough of these labels, I've observed that titanium white is an opaque pigment. Any inks that include white 6 are at least semi-opaque. Getting to know our pigments a bit better has its uses. Let's look at some other multi-pigment inks. This muted line of colors from Liquitex is fun, and the colors work pretty well together as part of the same palette. Why do they work well together? Well, it seems that all 5 of these have a splash of violet 23 in addition to whatever their main color is. That violet mutes the colors and unifies them. Yep, sometimes reading labels can be pretty insightful. It's a shame that most model painting lines hide the pigments from us. They've adopted a model where they mix up secret blends and give them silly proprietary names, like Orc Blood, Dwarf Skin, or Goblin Green. I found an FAQ from 2014 Vallejo that addresses this practice of hiding the pigments. Question: in your artist colors, you identify the pigments. Why do you not do the same in your model painting ranges? Answer: most of the tonalities in the model color ranges are the result of painstaking color matching to achieve the very same shade employed at a particular time for weaponry and armor. The naming of all the pigments employed for each color would take up too much space? Now, I really like the Vallejo line, but I don't buy that answer. Here's the back of a Vallejo paint bottle. It has text in 8 different languages declaring the paint to be opaque water-based acrylic for plastics, metals, etc. Shake well. I feel like they could have cut back to only 7 different languages or changed the font a bit and given us a list of pigment codes. At the very least, they could list all the pigments in their online PDF files. I think it's probably true that model paints tend to have more different colors in each bottle than artist paints. If you've ever mixed 2 model paints and gotten brown when you weren't expecting to, this may be the reason why. For calibration, most of the artist acrylics from Vallejo have a single pigment, and none have more than 3. In my Liquitex and Dollar Rowney inks, none have more than 4. I still have no idea how many pigments Game Color, Model Color, Games Workshop, or Army Painter have in each bottle. A little while back, Chimera introduced a set of single pigment acrylic model paints. I haven't tried these out yet, but it's such a refreshing idea, and I'm glad that they're on the market. I can still paint without knowing exactly what pigments I'm using. It's just sad that us curious painters don't always have access to that information. I guess the secrecy gets people to keep coming back to specific paint lines whenever they get a new German tank or a new box of Space Marines. It also allows for the marketing teams at these companies to make bold claims about the quality of their pigments, but we'll talk more about that later. And now, let's look at the most interesting 2-pigment ink that I own. Flame Orange. This is a mixture of Yellow 83 and Red 9. Yellow and red make orange. Why is that surprising? This caught my attention because it's a secondary color being derived from 2 primary colors. All of my greens contain a green pigment. All of my purples contain a violet pigment. But here is orange without an orange pigment, just a yellow and a red. The only other example I could find was turquoise. This isn't a mixture of blue and green, but instead a mixture of blue and yellow, and a bit of white. And again, interestingly, that titanium white is making the ink semi-opaque. It's all starting to make a bit of sense. The lesson here seems to be that color mixing isn't as easy and straightforward as our art teachers from grade school led us to believe. There's an advantage to using a violet pigment instead of a mixture of red and blue, and there's an advantage to using a green pigment instead of blue and yellow. In a future episode, we'll talk more about the little lies that our grade school art teachers may have told us about the color wheel and how easy it is to just mix up a secondary color. Mixing vibrant secondary colors from two single-color pigments is a bit tricky, and it's even harder trying to mix secondary colors from multi-pigment paints. The point here is that these paint lines aren't all mixtures of three primary color pigments. The paint lines I've looked at seem to be mixed from a few dozen pigments, of which 10 or so make very frequent appearances. Over the years, humans have used thousands of different materials as color pigments. A resource that's been really useful to me is this artistcreation.com website. It's a big old list of historical and modern color pigments. You can see all the pigment numbers, common names and nicknames, chemical structures, sources, and a bunch of other info on each pigment. It's interesting to me how much chemical diversity there is here, both in the pigments that were used historically and within pigments that are still used in modern paints. Pure materials which have a color are actually pretty rare. You've probably heard that perceived color comes from what is reflected off of an object. So if a material absorbs some wavelengths in the visible region of the electromagnetic spectrum and reflects others, we see color. Well, the vast majority of pure compounds are colorless. Water, alcohol, octane, sugar, salt, starch, diamond, styrene, baking soda, acetic acid, glass, acetone. Each of these will absorb electromagnetic radiation, just not in the human visible range. In nature, it's normally small impurities that give objects a color. Most of the materials in plants are colorless, but a % or 2 of chlorophyll makes them brilliant green. A rock with just a bit of iron oxide will be brown. Humans have sought out all of these compounds that are actually colored. We've synthesized others, and now we have a decent menu of available pigments. Not a perfect menu, but decent. Sometime in the future, we'll talk about how molecules absorb radiation and become colored. As different as they are, it's no coincidence that those organic pigments all have that alternating pattern of double bonds. The use of transition metal complexes as pigments also makes sense. Oh man, that's going to be a great episode someday. As a serious request, if anyone knows of a good source of visible absorption or reflectance spectra for paint pigments, let me know. I'm itching to dig into that stuff. I'm looking for a nice, meaty spectral library. I think it's fascinating to see the marriage of art and science. My background is as a chemist, and I'm trying to understand art supplies through that lens. For those of you with an art background, some of the stuff I've been saying may seem obvious or even like I'm missing the point. Still, I think that looking at a topic from different angles can be invaluable in getting an understanding of it. In this episode, we're sort of reverse engineering art supplies to get to know them better. Someday, we'll go more into the chemistry and physics. I assure you that I'm excited to use terms like quantum mechanics, molecular orbitals, conjugated pi systems, and charge transfer complexes on this channel. Before all that, let's see if we can squeeze any more useful nuggets out of these art supply labels. This powder was sold to me as phthalo green, and I actually don't know for sure if it's PG7 or PG36. Check this out. Liquitex uses green 7, and Dollar Rowney uses green 36 for extremely similar inks. Looking at the structures, these are distinct and different compounds, but it makes sense that these two are very similar in color. Replacing chlorine atoms with bromine atoms is often a subtle change. Different pigment molecules sometimes give very similar colors, and manufacturers may have a choice of how they get phthalo green, Hansa yellow, or carmine red. Over the years, some pigments have been made obsolete. Those that are still viable come with their own special blend of advantages, disadvantages, properties, and quirks. While we're on the subject, changing all of the chlorine atoms to hydrogen atoms gives us phthalo blue. Swapping halogen atoms for hydrogen atoms is a much larger chemical change. Phthalo blue is still a very strong pigment, but the hue has definitely altered. There are chemical reasons for why pigments absorb different colors, and there are patterns to be found here if you're inclined to look closely. Oh hey, our homemade paints are ready. They're a bit thick, but let's see how they work. Now, obviously, you don't need to know anything about chemistry to be a painter, but sometimes having a little context helps. It's great when bits of our knowledge and experience start to connect, and the world makes a little more sense. So, can we use our newfound knowledge to shop smarter? What marketing claims have you heard paint vendors make? Ultra-fine pigments. Have you heard that one? The pigment grain is so fine that you get buttery smooth paint. Such luxury. Well, here's the deal. Paint pigment can be ground as fine as the manufacturer wants it. None of the bonds and pigment molecules will be damaged by physical grinding. If you're a company and you want to sell paints with fine-grained pigments, that's a great choice, but it's hardly worthy of a price markup. A company bragging about fine-grained pigments is bragging that they let their coffee grinders run a few minutes longer. Good job, team, but maybe we can aim a little bit higher. I too own a coffee grinder. Okay, how about this phrase? Highly pigmented. This is another real description. In fact, you just saw me take my vials of homebrew paint from low pigment to high pigment. The highly pigmented stuff does have better coverage, and it also does cost more to make. Acrylic Medium is cheap. The most expensive thing in those vials is the pigment. Highly pigmented. If they're telling the truth, that is something that I'd be willing to pay a bit more for. In fact, just the choice of buying bottle paints instead of craft paints is making the choice to pay more for paints with a higher pigment load. Next up, how about this marketing speak? We use higher quality pigments and higher purity pigments. This could be a real description. There are multiple pigments or pigment combinations that can be used to give a particular hue. Pigments are commodities, and price per gram can vary drastically between different pigments and different sources. Keep in mind though, a more expensive pigment isn't always a superior pigment. So it's true that some paint brands really may be putting more expensive pigments into their paints. Still, if a company says they're using only the highest quality pigments, but they don't bother listing them on the bottle, well, I reserve the right to be skeptical. Ultimately, companies are gonna say what they've gotta say to sell their product. As consumers, it behooves us to take all that marketing with a grain of salt. Experiment with different brands and chat with people you trust to find the supplies that work for you. There are tons of viable ways to make a red paint. Some colors have a better menu of available pigments than others, but still, manufacturers make their choices and some paints just come out nicer than others. Knowledge is power. The better we understand our art supplies, the more we can customize our palette to fit our style. Picking and choosing our favorite colors from multiple paint lines is a perfectly reasonable thing to do. When you find a great color, remember to share it with your friends. We're gonna wrap it up here for this time, but I'll definitely be doing more hobby science videos on color. This is a vast and fascinating topic, and we've barely just dipped a toe in it. Like and subscribe for more hobby science, send me links to good quality spectra of pigments, and, as always, thank you so much for watching.